Okay, so today you guys are going to be able to classify numbers, which might be review. You're also going to be able to write numbers in standard form, and you're going to also learn the way that IB wants you to round. Okay, they do have a special way they want you to round different numbers. When you get a decimal. Okay, and so we're going to talk about that as well today. So let's start off with our classifying numbers. Like I said, this might be a review from pre-cal or maybe even algebra 2. Okay. So, you want to go? All right. Ooh. There are different numbers belong to different sets. Okay, different numbers belong to different sets. These are the four really and truly that you need to know for IB standpoint. Of course, you have your real numbers. Okay, you're either going to have real numbers or imaginary numbers. You have your rational numbers, your integers, and your natural numbers. And those are the respective symbols that go with those different number sets. Okay? And if you learned about your number sets back in pre-cal or algebra 2, whole might have been another one that you learned about. That's not, I feel like outside the U.S., that's not a number set that's classified. They don't use that to classify. Okay? So these are the main four. Real numbers, rational numbers, integers, and natural numbers, okay? We'll start with the natural numbers first, okay? Anybody know what a natural number is? A positive whole integer, okay? They are your counting numbers. Natural numbers are your positive whole numbers. They're used to count, put things in order, okay? Whenever someone tells you to count off, you always start with 1, then 2, then 3, and so on and so forth. So those are your natural numbers. Okay? And so instead of just saying, hey, this number, is it a natural number or not? Instead of doing that, let's do a little bit of math. So on your desk, what I want you guys to do is I want you to find the value of I, double I, triple I, and 4I, when A is 5 and B is 7, and I want you to determine whether or not they are natural. Okay? So I want you guys to do that on your desk. So, when A is 5 and B is 7, I is what? Anyone? It is 12. Okay? Is that natural or not natural? Natural. Yes, very good. A times B? 35. Natural? Yes. A minus B? Natural? Awesome. And B minus A? Natural? Awesome. Okay. Hopefully no one needed a calculator to confirm that 5 times 7 was 35. Correct? Good? All right. Now you have your integers. Integers are your positive and negative whole numbers, including 0. Okay? So think of your number line. Okay? On a number line, old school algebra 1, you had 0 in the middle, then 1 and negative 1, 2 and negative 2, 3 and negative 3, so on and so forth. Okay? Those are your integers. What was the symbol for integer again? It's a Z. Okay? Z, that's kind of, not, associated with like any part of the word. Okay? On your desk, I want you to solve each equation. Let's see if we can solve a simple equation. And then I want you to state whether or not, I spelled whether wrong, don't judge me, the solution is an integer. Okay? So go ahead and solve this. Solve these two. Yes. Julia, how do you solve A?
Move 5 from the left side, subtract.
Okay. And what'd you get?
6.
Very good. X equals 6. Okay. And so Logan, is that an integer?
Yes.
Very good. All right. Brooke, how do I solve B?
Divide by
Awesome. And what is X? Awesome. And Muhammad, is that an integer?
No.
Awesome. Simple enough, yes? Okay. So far, you guys are giving me the reassurance that we can solve simple math. Yes. All right? Rational numbers. Okay, these are numbers that can be written in the form of a quotient or be written as the quotient of two integers, okay? So two integers. Remember, integers are positive and negative whole numbers. Quotient means division. Answer to the division problem. It's the division. Okay? So 7 can be written as a fraction. How can I write 7 as a fraction? 7 over 1. Same thing with -3. Same thing with 0. Okay? Every whole number is a rational number because it can be written as a fraction. Okay? What about -1.5? That is rational. How can I write it as a fraction? -3 over 2. Okay? So any terminating decimal can be written as a fraction. Okay? So any terminating decimal is also a rational number. You also have your repetition ones, such as 0.33333 repeating. What is that as a fraction? It's 1/3. Okay? So any repeating decimal is also a rational number, and so on and so forth. Okay? So what I want you guys to do is I want you to express. This is kind of more IB wording. Okay? I want you to express 1.3 with the line over it as a fraction, and then hence I want you to calculate what is the sum of 1.3 repeating plus 4 over 5, and give your answer as a fraction. Okay? I want you guys to do that on your desk. How do I express 1.3 with the bar over it as a fraction? Anyone? It is 4/3. Okay? Technically it's 1 and 1/3, but we haven't done mixed numbers in what? Elementary school? Improper fractions. So 4/3. So, and you pretty much will want it as an improper fraction in order to add it to 4/5. This word here is used very often. Hence basically means in the IB world is you basically just found an answer. Use that to help you solve this next one. Okay? So hence, taking 4/3, add it to 4/5. Okay? In order to add fractions, what do we need? What was that common denominator? 15. So then we have to basically multiply the first fraction by 5, the second fraction by 3, add them together. What was our numerator? It was 32. So our answer is 32 over 15. Are both of these rational numbers? Yes, they are. Good stuff. So, like I was saying before, if a number is rational, it can be written as a quotient of two integers. The decimal expansion is finite, which means that it ends. Okay? It's also a decimal that is non-terminating. In other words, it doesn't end, but it has reoccurring digit or a pattern of digits. Okay? Those are rational numbers. All right? Those are rational numbers. Now, on your desk, you may need a calculator for this one. I'll let you use it. Yeah, go ahead. I can't remember about the second one. I want you to go ahead and calculate the value of these two, A, which is x plus y, that quantity squared, and B, square root of x minus 5 over y, when x is -4 and y is 1/2. And then I want you to state whether or not they are rational numbers and justify your answer. Okay? And then justify your answer. Do that on your desk. So we have these two different expressions, and we have these values for x and y, and we're trying to figure out what is the value, or calculate the value of the two when x is -4 and y is 1/2. Okay? So hopefully, raise your hand if you showed your work. Okay? As you should of some kind, because you never know where those points may be on those IB questions. You might get a method for correct substitution of the values. So we have -4 plus 1/2, and we have to square it. So that's basically -3.5 squared, or did anybody put that as a fraction? 296 over 16. -7 over 2. This definitely would be a lot easier to square than -3.5. So what is that when you square it? 49 over 4. And there's nothing wrong with leaving an answer as a fraction, okay? Because if anything, this is the more exact answer than trying to round the decimal, or even figuring out what the decimal is, especially since there's no calculator. Is that rational? Yes, it is. As I said it pretty much. Keyword, it is a fraction. So yes, fraction. Okay? What about B? When you plugged in, you would have had -4 minus 5 all over 1/2. What's -4 minus 5? -9. So this is basically the square root of -9 over 1/2. How do you divide a fraction within a fraction? Keep, change, flip. So then this basically becomes -9 times 2 over 1, which is what? So this is the square root of -18. That is the value of x. I'm sorry, no, that's the value of the expression. The square root of -18. Is that rational? No, it is not. Actually, what? It's imaginary. It's not even a real number. You can't take the square root of a negative number. What happens when you take a square root? You're going to have an I. And how do you simplify the square root of 18? So then it becomes 3i squared. Yes. So that simplifies down to. So no, the negative underneath the square root. Questions?
So your square root numbers, like it would be square root 18, it would be rational.
If it was a square root of 18, then it would not be rational. Okay, because it would simplify down to be 3 square root of 2, and the square root of 2 is one of those decimals that doesn't have a reoccurring pattern. Yeah, so that would actually be irrational. It would just be real.
You can stop at negative square root of -18. You wouldn't have to go down to 300.
You could stop there. Questions? I'll review things, yes? Okay. So, like I say, you have irrational and rational numbers. The ones that do not have a recurring pattern, those are your irrational numbers. Square root of 2, square root of 7, pi, so on and so forth. Okay? So pi is an example of an irrational number. 22 over 7, which some people say, people use as pi, that is a rational number. Okay? It is not exactly what pi is, but it's a close approximation to what pi is. Okay? Rounding. How does IB want you to round? Okay? Let's just make sure we know how to round. Everyone knows that 5 or more you round up, and less than 5 you go. Okay? Sometimes you may see the DP. It'll say, round to 1 DP. DP, what do you think stands for? Decimal place. Very good. So 1 DP would be the nearest tenth, 2 DPs would be the nearest 100, 3 DPs the nearest 1,000, and 4 DPs the nearest 10,000. Okay? So sometimes you may see this notation over here. This is just decimal place. Okay? Good to know, everyone. Remember how to round. Okay? But the true rounding test, we're not even going to do that. I'm not even going to waste time on it. All right? It's significant figures. Okay? Significant figures also comes up in one of the science courses that you guys take. Which one is it? All of them? Oh, yeah. Okay. So you might have an idea of how to round with significant figures, but I don't know if what they told you was correct. So this is how you correctly round with the significant figures, okay? The rules. All non-zero digits are significant. So in the blue, you have an example, 2,578. That is an example of 4 significant figures because they're all non-zero digits. So 2 is your first significant figure, 5 is your second, 7 your third, 8 your fourth. Okay, so all non-zero digits are significant. The second rule, zeros between non-zero digits are significant. Okay? So if you have a 0 that's in between 2 non-zero numbers, that 0 is a significant figure. So in this example of 20,004, all 3 of those zeros are significant. So that's an example of a 5 significant figures. The third rule, zeros to the left of the first non-zero digit are not significant. Okay? So all of those zeros, so if a number starts with a 0 and continues to have zeros after the decimal place, all of those zeros are not significant. Okay? The count for significant figures starts with your first non-zero number. Okay? The count starts with your first non-zero number. So this example of 0.023, that is two significant figures. 2 is the first significant figure, and 3 is the second significant figure. Okay? But if the zeros come after a non-zero number to the right of the decimal point, then they are significant. So this right here is an example of 3 significant figures, 0.100. So both of those zeros after the 1 are significant. Okay. 4 rules when it comes to significant figures. You are allowed 1 rounding error in like the entire paper 1, the entire paper 2, you're allowed 1 rounding error. So let's say, you just continue to round incorrectly, then you're only penalized 1 time. Unless the problem told you to round a specific way, then you're penalized there as well. Okay? That's exactly how I treat your test. Okay? If you don't round correctly, you'll lose that rounding penalty, and I indicated with an R -1, and I circle it. That lets you know that in this problem, this is where you lost your rounding penalty, and then you weren't penalized from there on out, unless the problem told you to. Okay? Questions on that? To try these problems on your desk. SF, just like GP, would stand for significant figures, okay? So I want you to write down 24.31 correct to 2 significant figures, then B to 3 significant figures, and then C to 2 significant figures. Go ahead and do that on your desk. I'll take a volunteer for A. When you round 24.31 correct to 2 significant figures, what do you get? Anyone? With confidence, anyone?
24.
It is 24. Okay? Yes, the answer is 24. Okay? Another key set of words that IB uses is write down. If it's write down, that means there is very little to no work needed, okay, for the problem. All right? Or it's just staring you in the face like the answer is a picture. All right? But yes, this is just 24. No need for 24.00. 1, 2, it suffices for the whole number part before the decimal, so you just leave it as 24, no decimal needed. Any questions about A? Okay. What about B? Anyone?
1010.
1010, so 1010.
Yeah.
You guys agree? Yes. Here's your first significant figure. It starts with your first non-zero decimal, non-zero digit. So the 1 is significant, and both of these zeros are significant. So at this point, you would stop, and you would look at the number after to see if it needs to stay in 0 or round up to a 1. Since it's 5, you do round up, but you got to have a placeholder afterwards, okay? You just can't have a 4-digit number turn to a 3-digit number, okay? And what about C? It says 0.3. 0.3? 0.30. Which one is it? Why is it with the 0? Because it makes it 2 significant figures. 0 is not your first one. The 2 is. And then the 9. So you would stop here, and that 8 would cause you to round that 9 up, which will cause the 2 to round up, so you do need to have that placeholder for that second significant figure. Did anybody get all of them right? Stop. So I saw one hand, and I heard some mm-hms, but I wouldn't like that visual confirmation. So raise your hand if you got them all right. Okay. That's all right. That's why we go over it. I don't want to make any assumptions, okay? And just because you get this right now doesn't mean that you won't lose your rounding point later. Never fails. It will be year 2. We're about to test, and folks are still losing their rounding penalty. Okay? Just be aware. I want you guys to give this a whirl. You do need your calculator for this one. Okay? If you don't have one with you, maybe the person beside you or someone in your general area could do the calculation for you guys. So in that way, we can write down the values R, giving the full calculator display, and then rounding each part to 3 significant figures and 2 significant figures. Don't say. So, what is the full calculator display? Anyone? 0.54. What do you say too fast? 666. Yes, that is what it is. When it says write down the full calculator display, you don't leave any of them digits out from that graphing calculator. You type it in and you get that, okay? Make sure that the entire denominator is in the denominator. So if I want to round that correct to 3 significant figures, that would be what? Anyone? 498, very good. So 4 is your first, 9 is your second, 7 is your third. That 5 causes a 7 to round up. What about 2 significant figures? 500. Very good. Because that 7 will cause the 9 to round up, which will cause the 4 to round up, and you need to have a placeholder. It was a 3-digit. Good? Mm-hmm. How are we on rounding? Pretty good on the significant figure part? Always be careful with your rounding. Like I said, it'll be year 2, and we're still having rounding issues, okay? If you have to use an answer from a previous question, let's say it's like a 3-part question, an A, B, and a C, and you rounded in part A, okay? Use the full answer to solve part B. Never use the rounded answer, okay? Does everybody understand that? All right. With that being said, unless it specifies in the problem, you always round to 3 significant figures. Unless the problem tells you to round to 2 significant figures or 3 decimal places, you always round to 3 significant figures. Okay? When you get your test, there'll always be a cover page, and the cover page will always look the same, okay? Because it's the same cover that you get on the day of your exam, except it's not, one part might be altered because it's not the real thing, it's just, the test of class. But the last line will say, unless otherwise stated, leave answers exact or correct to 3 significant figures, okay? So you can either leave your answer as 49 over 4, and that would be fine. But if I sit there and I divide 49 by 4, I can either also write this, because this is technically exact because it's an ending decimal, or you could write it as 12.3 rounded to 3 significant figures, okay? So, exact, 3 significant figures. This also works because it's in, but let's say it was one of those that just kept on going forever. 3 significant figures, okay? Everybody understand that? Last thing we're going to talk about today is standard form. Standard form is basically old school scientific notation, okay? Or what you guys know to be scientific notation. It is a way of writing very large numbers or very small numbers without writing a lot of zeros, okay? The form in which standard form is written is A times 10 to the k power, where A is a number in between 1 inclusive and 10 exclusive, and K is an integer. Okay? And K is an integer. Everybody remember scientific notation? Or standard form, I guess I should say. When I look at this example of this large number down here for A, where's the decimal? Huh? Behind the last zero, okay? So back in the day, you guys used to be like, okay, well, I just need to count. That's 1, 2, 3, 4, 5, 6, 7, 8. You want to make sure you bring the decimal all the way back so that the value of A is in between 1 and 10. Familiar? Mm-hmm. So we'll have 2.57, that's your A, times 10 to the what power? 8. The number of places that you moved it back. Since the decimal's here for B, I'm going to move it over 1, 2, 3, 4 places, making sure that number is in between, the value of A is in between 1 and 10. So that gives me 4.3 times 10 to the what power? Negative 4. Okay? If you have to move the decimal to the right, it's negative. If you have to move it to the left, it's positive. Or if the number is really, really small, the exponent is negative. If the number is really, really big, the exponent is positive. And that is standard form. So now we refresh our memory about classifying numbers, writing numbers in standard form, and you also learned how IB wants you guys to round. Are there any questions?